In this lecture, I'm going to convince you the power of pipelines and a common mistake that might happen if you try not to use pipelines. Okay, just import some things we need. Let's use a California housing data set. Now what I want to do here is I'm going to perform a train test split. So I'm going to say from scikit-learn model selection import train test split. So this is a function here. So the way this works is that I can split my data into a train test split where I'm going to train the model on the training set and evaluate how well the model does on the test set. And this is a great way because the test set is data observations the model didn't learn from, so it'll give us a good idea of how well the model will do with data it has not seen before. Train test split, we pass x and y, so it's going to perform these splits. We have to tell it the test size. In other words, what fraction of our data should be devoted to testing. It's customary to use anywhere from 10 to 30%. So I'm going to say 0.2. I'm also going to set the random state to 0. So let me explain what's going on here. This splitting process is random, but if I want the same randomness every time I use this function, I need to set the random state. And this is very useful for reproducibilities. If I'm always generating a different train test split, then I will get different results when I evaluate the model. But by setting the random state equal to some number, in this case 0, I'm saying go ahead and use the same randomness every time we use this function. So by doing this, the results that I'm going to show you here will be the same if you follow along. Okay, I perform the train test split. Now I'm going to be stubborn. I'm going to be stubborn and not use pipelines. And in my workflow, I'm going to scale the data and then train it on a linear regressor. So I'm going to do that there. So I'm going to say scalar equals standard scalar. Linear regressor. There's my linear regressor there. And I'm going to first scale my data. So I'm going to say x train scaled is equal to scalar fit and transform. Remember, the fit and transform is a method I can use to automatically fit the model using the data and perform the transformation all in one call. And then the model is going to be fit with x train scaled and y train. Okay, that worked out. Let's see how well the model works. Let's evaluate on the test set. So, well, let's first evaluate the model, how well the model does on the training set. Okay, so it's about 0.61 R-squared value on the training set. Let's see how well the model performs on the test set. So I say, okay, lr.score test y test. Let's see how well it did. Ooh, negative 3,000 R-squared value. Typically, R-squared values range from 0 and 1. You want a value closer to 1 as possible. But here, I got a very large negative number, negative 3,000. Crap. Is my model really that bad? Is it really that bad? I don't know. Let's go ahead and see. And let's see what my mistake here was. Well, notice the model was trained on a scaled data set. But I am using the model on using observations that haven't been scaled. X-test hasn't been scaled. What I need to do is I need to first apply the transformation. And since I'm not doing pipelines, I have to do this manually. Gotta scale this, scalar.transform, pass the x-test, and then I can use the model. Okay, 0.59 R-squared value. So not much different from the training set. So yeah, notice there what my mistake was that I quickly jumped and used a model on the unscaled data. And it got a horrible result because the model's expecting scaled data. Data has been rescaled. But it's getting values that have not been scaled. It's like if you train the model to make predictions using features like temperature and you're using Fahrenheit and you pass data in Celsius, of course the model isn't going to work very well. Same thing with like square footage. Let's say the model was trained on a unit of area that is dimensionless, and you pass it observations in which the area is in square footage or centimeters or something weird. It needs to be scaled. Of course, the model is going to perform very poorly. So, yeah. So I had to manually do the transformation, and then pass the transform data to the score method. Not only do I have to manually transform it myself, but I'm also prone to mistakes here, where I accidentally forget to apply the transformation before I use the model. And this is just a simple workflow of 2 steps. Imagine if I have multiple steps, feature unions, multiple pipelines, very complicated workflow. I'd have to keep track of all the steps and all the different intermediate variables that I'm creating. And then hopefully I don't make this mistake that I did here. So I made that mistake on purpose. So hopefully you've been convinced the power of pipelines in this short lecture.